In this section, we will cover the remainder of the analytical techniques, including clustering, correlation, regression, frequent pattern mining, hypothesis testing, and descriptive statistics. Remember that there is more information and detail on each of these techniques in the online background and supporting documentation for this course. Clustering is another crucial analytical technique that splits data into groups when pre-assigned categories or classes are not available. It is important to note that there are numerous types of clustering techniques. In this section, we will examine two of those techniques in depth in order to give you a better idea of how these techniques can be used. The k-means clustering algorithm is a process by which objects are classified into a number of groups so that they are as much dissimilar as possible from one group to another and as similar as possible within each group. K-means clustering is a grouping of similar things or data. Let's say a business wants to organize customers into groups or segments based on similar traits, product preferences, and expectations. Segments are constructed on the basis of the customer demographic characteristics, psychographics, past behavior, and product use behaviors. Let's look at another example of clustering. A business might wish to conduct a discount analysis and customer retention study in order to help the organization target discounts to specific customers and visualize segments of sales groups based on discount behavior, as well as customer churn, to identify segments of customers on the verge of leaving. Limitations for use of the k-means clustering algorithm include the fact that the number of clusters must be determined beforehand. You should also note that this technique does not yield the same result with each run, since the resulting clusters depend on the initial random assignments for group centers. If the data is input in a different order, it may produce a different cluster if there are too few data points. So you'll want to have a large enough data set. Keep in mind that k-means is suitable only for numeric data and that variable standardization is necessary if you wish to achieve the right outcome, and that empty clusters can be obtained if no points are allocated to a cluster during the assignment step. Hierarchical clustering is a process by which objects are classified into a number of groups so that they are as much dissimilar as possible from one group to another and as similar as possible within each group. This technique might be used to analyze movie ticket booking for website users. Data can be grouped into movie freaks, moderate watchers, rare watchers, based on their past movie ticket purchasing behavior, such as the number of days from the last movie seen, the average number of tickets booked each time, the frequency of ticket bookings per month, and other factors. Keep in mind that this technique is relatively time-consuming as compared to other clustering methods, and based on the distance calculation method chosen, this algorithm may sometimes get influenced by outliers. Also, the distance measure used to separate the data points in a cluster is affected by the scale of variables, so scaling normalization of variables is necessary prior to clustering. Another analytical technique that is crucial to business analytics is correlation. In this category, we will look at two correlation techniques. The first is the Pearson correlation. The Carl-Pearson correlation measures the degree of linear relationship between two variables. Like other forms of correlation analysis, the Carl-Pearson method measures the strength of relationships between only two variables, without taking into consideration the fact that both these variables may be influenced by a third variable. Here is an example of where it might be appropriate to use the Pearson correlation. Let's say a bank wants to find the correlation between income and the credit card delinquency rate of credit card holders. This graphic depicts the results of that assessment. The limitations of the Carl-Pearson method include the fact that correlation is affected by outliers, and that the correlation method measures the strength of relationship between only two variables, without taking into consideration the fact that both these variables may be influenced by a third variable. The Carl Pearson technique can handle only numeric data, and in the case of categorically ranked variables, these need to be converted into numeric ranks in order to use the Pearson correlation method. Now let's look at the Spearman rank correlation. The Spearman's rank correlation is a measure of correlation between two ranked or ordered variables. This method measures the strength and direction of association between two sets of data when ranked by each of their quantities. This analytical technique might be used when an educational organization wants to assess student ratings based on two different sources of observation, or when a market research agency wants to cluster various survey responders into groups based on the rank correlation output. The limitations of the Spearman method include the fact that this correlation method measures the strength of the relationship between only two variables, without taking into consideration the fact that both these variables may be influenced by a third variable. The Spearman technique can handle only numeric data, and in the case of categorically ranked variables, these need to be converted into numeric ranks in order to complete the analytical technique. In the category of regression analytics, we will look at two techniques. Regression analysis predicts change in one variable based on change in one or more variables. The first regression technique is simple linear regression, a statistical technique that attempts to explore the relationship between one independent variable, x, and one dependent variable, y. This method helps a business identify the relationship between x and y and the nature and direction of that relationship. A business might use simple linear regression when it wants to measure the impact of temperature on yield in order to better predict the availability of product and how the yield will affect inventory and sales. Simple linear regression is limited to predicting numeric output. The dependent variable has to be numeric in nature, and in a simple linear regression, the minimum sample size should be 58. This technique handles only two variables, one predictor and one dependent variable. But usually there are more than one predictor correlated with the dependent variable, which can't be analyzed through simple linear regression. The second technique is multiple linear regression. Multiple linear regression is a statistical technique that is designed to explore the relationship between two or more variables, x and y. It is useful in identifying important factors, x, that will impact a dependent variable, y, and the nature of the relationship between each of the factors and the dependent variable. Linear regression is limited to predicting numeric output, so the dependent variable has to be numeric in nature. This technique might be used by an agriculture production firm to predict the impact of the amount of rainfall, humidity, and temperature on the yield of a particular crop. Or perhaps a retail company might want to measure the impact of product promotions and holiday seasonality on product sales. The multiple linear regression technique is limited to predicting numeric output, and a dependent variable has to be numeric in nature. The minimum sample size should be at least 20 cases per independent variable. Multicollinearity is a situation when two or more independent variables are highly correlated with one another, and these should be removed before running the model. In this graphic, we see an example of frequent pattern mining. Frequent pattern mining, also known as association rule mining, is an analytical process that finds frequent patterns, associations, or causal structures from data sets found in various kinds of databases, such as relational databases, transactional databases, and other data repositories. Given a set of transactions, this process aims to find the rules that enable us to predict the occurrence of a specific item based on the occurrence of other items in the transaction. Frequent pattern mining could be used if a retail store manager wanted to conduct market basket analysis to come up with a better strategy of product placement and product bundling. Another example of possible application of frequent pattern mining would be when a bank marketing manager wishes to analyze which products are frequently and sequentially bought together. Each customer is represented as a transaction containing the ordered set of products. This analysis would allow the user to predict which products are likely to be purchased simultaneously and sequentially. Limitations for the frequent pattern mining technique include the fact that processing time for running this algorithm is relatively high when compared to other algorithms due to the millions of transaction-level data in the input. The user must also possess a certain amount of expertise in order to find the right settings for support and confidence to obtain the best association rules. Now let's look at hypothesis testing. Hypothesis testing answers many questions, examples of which are illustrated on this graphic. It will help you determine whether two samples are different, whether medical treatments are effective, whether two dimensions under consideration are related or independent, and many other refined determinations. Hypothesis testing techniques include the chi-square test of independence, used to determine whether there is a statistically significant association between the two categorical variables. This technique is used to determine if the relationship exists between any two business parameters that are of categorical data type. An enterprise might use chi-square to determine if there is a relationship between the region in which a product is purchased and the product or category of product that is purchased. One might use this technique to determine whether gender is related to a voting preference, or whether the two data points are independent and unrelated. The chi-square test of independence can be applied on only two categorical variables, in other words, for two dimensions, and the number of data points should be at least 50. The frequency count for each dimension value combination, or each cell value of the contingency table, should be at least 5. Keep in mind that this technique displays the presence or absence of an association between two parameters, but it does not measure the strength of association, as the correlation technique would. The one-way ANOVA test is used to determine whether there are any statistically significant differences between the means of 3 or more independent, unrelated groups. An ANOVA test is a way to find out if survey or experiment results are significant. It will determine whether you should reject the null hypothesis or accept the alternate hypothesis by testing groups to see if there is a difference between or among them. Let's look at the example displayed here to see how we can use one-way ANOVA test to determine if out of 3 or more rivers, at least 2 of them differ significantly from each other in terms of pH, TDS, and other factors. You might also use this technique to determine the effect of 3 different diets on a person's cholesterol levels and weight. When using the one-way ANOVA test, keep in mind that the total data points should be more than the total number of groups. Be sure to remove outliers from the data before applying this technique, as this method is sensitive to outliers and will lead to incorrect results if outliers are not removed. Now let's look at the independent sample t-test. This test is a statistical method of hypothesis testing that determines whether there is a statistically significant difference between the means of 2 independent samples. For example, as in this displayed result, we might use this technique to determine whether male employees in a particular company earn more than female employees, or one might use this method of analysis to determine whether the average value of a sedan type of car is significantly different from an SUV type of car. The independent sample t-test can be applied on only 2 samples, 1 dimension with 2 values, and 1 measure at a time. And observations within each group must be independent. The values in each group must be normally distributed, and the number of data points should equal at least 30. The last hypothesis testing technique we will review is the paired sample t-test. This technique is used to determine whether the mean of a dependent variable, e.g. weight, anxiety level, salary, reaction time, is the same in 2 related groups. For example, One might consider two groups of participants that are measured at two different time points, or two groups that are subjected to two different conditions. Or one might use this technique to compare unemployment, GDP growth, or other factors for a time period during which one president was in office versus the results in these areas during the period another president was in office. Paired t-test is used to evaluate the before and after of a situation, treatment, condition, and other factors. The paired sample t-test can be applied on only two samples, one measure and one time dimension or a sequence ID, to decide the cut point for division of measure values into pre- and post-samples. To use this technique, the number of data points should be at least 30. The next technique we will review is descriptive statistics. This technique helps users to describe and understand the features of a specific dataset by providing short summaries and a graphic depiction of the measured data. There are numerous methods of descriptive statistics, including mean, median, and mode methods of averaging data and percentile, quartile, skewness, and standard deviation variance methods, as well as plotting methods like box plots and histograms. To better understand these methods, let's take a moment to review each one. Mean is the average of all the data values. This measurement can be biased in a case where there are a significant number of outliers present in the data. Median is the value in the middle when the data items are arranged in ascending order. The measure is relatively robust where there are a significant number of outliers present in data. Mode is the most frequently occurring value in a series of data. If there is no repeating value in the data, there would be no mode. And percentile represents a percentage position in a list of data. For example, the 20th percentile is the value below which 20% of the observations may be found. Descriptive statistics can be used to reveal the deviation of stock prices over a one-day period, to find out the average age and income for a particular type of product category purchased, or to identify the most popular dish served in the restaurant, or find out the most frequent rating given by customers for a given movie or restaurant, or the most frequent size or category of a sold product. Use descriptive statistics when you need to understand what is going on in your company at an aggregate level, and when you want to summarize and describe different aspects of your business. There are no specific limitations for this type of analytical method. This concludes our review of the various algorithms and analytical techniques you may use in your role as a citizen data scientist. Remember that you do not have to be an expert in these techniques because your augmented analytics solution will provide the foundation, guidance, and recommendations to help you work through your analysis. But as with any other tool, topic, or area of focus, you're bound to get more out of the exercise if you have a basic understanding of the techniques and if you familiarize yourself with the names, uses, and approaches to analytics. Once again, remember that additional detail and information for all of the techniques we have discussed is included in the supporting documents for this course.